Well, greetings, good web folk. Today we are going to continue making unique candlestick and learn about Go structs. Structs are basically a way of organizing grouped data so that you can find the right parts of it as you need. So in our case, each player has a deck of 13 cards and 3 cards in their hand. They also have a score for all of the points they've won so far. So these 3 things will belong in a struct. We're also going to introduce a new way of looping using the range keyword to grab all of the elements out of an array in turn. But before we get there, we have some minor changes to make to the code so that it answers the questions correctly, and we have to go through last week's challenge. I'm going to finish last week's challenge first. So, last week I asked you to make a new testing method for the beats and contains method. I'm just going to bother with contains here on camera, so we're going to make a very simple testing method for this function, which returns the number of elements in a slice that match the comparator. So here's the slice, AR is the slice, C is the comparator, and it goes through and just adds up to get the right answer. So here we can write our test function. Notice with this, it's actually this is what's called a pure function. It takes this data from here and it returns an answer, and it doesn't change anything, which is great because that means it's super easy to test. This is true for beats and it's true for decide trick, which make them really good for testing. So if you can make all of your back logic to your program as pure as this as you can, then that makes testing super easy, and it's easier to find anything else that goes wrong. It's not always possible, and anytime you need user interaction, you really lose the ability to make stuff pure, but where it can be pure, it's kind of nice. So we need to make a struct first, and a struct is basically a way of shaping your data, as I've said, and this struct, this is to make another tabular test for the thing type, and this is contains table, so that's and that is a struct. So a type can be anything. You can actually have a type that is exactly the same as an int, but I feel like most of the types you're going to want to make are a new struct. And you just name each of the parts of the struct as you want to. So, ooh, didn't quite mean to hit that button. Here we go. So this struct will contain a question array, and that will be a slice of ints. Oops. And it will contain a question comparator, and that will just be an int. Those are the 2 things that we actually needed to add. And then we've got our result. Okay, now this is the expected result. I'm just going to call that, and it will be an int as well. And then we're going to make our function, which is func, and again it has to begin with a capital because the testing thing needs it, and I think it needs to begin with the word test. I'm going to leave it with the beginning, the word test. Test contains, because that's what we're doing. We're testing the word contains, and this has to take a pointer to a testing.t, and we've called that t, but we could call it whatever we like. Doesn't return anything. And here we want to begin by making our table of tests. Now, because I basically want to test on the same array for different cases, so I'm just going to make that test array first. We could do this a couple of ways, but AR1 equals, and this will be an int array, int, a slice of ints, and this will contain this data, 4, 7, 3, 4, 6, 6, 4. Okay. Brilliant. And the next thing we need is our table of tests, and that's what we're going to use our contains table. So tests equals, and this is a contains table, and inside this table, this is where you, this should be a colon, this should be a colon. Actually, it's an array of them. That was I think I've called it the wrong name. Contains test, and this will be the same. And then we'll have the table, and here each of these tests will be a new individual, not a slice of them, a contains test. And the first parameter is AR, that's to represent the QR here. So we're just going to put that in. The next thing will be a test, what we're asking. So the first thing we're going to ask is how many 4s there are. And our expected result is 1, 2, 3. Yep. And then you put a comma, and then we make our new one. I'm going to yank and put these down like that. We can test for 7s, for which of course the result should be 1. We can test for 3s, for which the result should be 1. We can test for 6s, for which the result should be 2. And we can test for something that's not in there, which is always a good idea. Contains test AR 15, and we'd expect a 0. Yeah. So that's our test structure, and then and now here's where we introduce range. So the normal way, the way I've shown you to do this, and the way I would hope you have so far, would be for I colon equals 0, semicolon I is less than length of tab semicolon I plus plus, and inside here we'd be looking at tab at I. We'd be working with tab at I. But because we're just working through every single element of the array, there's a slightly easier way of doing this. So we're going to use the keyword range. Now range returns two things, a key and a value, and colon equals, and then we put, so colon equals assigns these two the new name, and then range keyword of tab, which is our table. And so now, rather than us having to do the I and the keeping count ourselves, the program does a count, and it puts the index into, I've called it K, I could call it anything I like. I could call it I if I wanted. I tend to call it K because it helps me to think of key and value. So this is for maps, where you can put something in and have access to different parts. Although actually we don't need that key at all in this test. So what you do if you don't want to use something, and actually you have to do this, is you have to use an underscore, because if you don't use it, if you define it and you don't use it, it will complain. In fact, I'll show you. I'll call it K, and we won't use it, and we'll see it complain. So res colon equals contains v dot QARR, so that's that part, and v dot QCOM. Okay, so this should actually run the contains test, and the result will be how many are in there. If res does not equal our expected result, which is v.exp, then we have to fail the test, right? T.fail, and we should probably print a message that says why. So funct.printf %s, comma, %d, comma, %colon, expected, %d, comma, got, %d. So we've got 4 things we're outputting here. First, we're going to output the array, which is v.qr. Oh, we're still in quotes. Stick a new line on. Close quote. v.qar, v.qcom, and then we expected v.exp, and the result was res. There's a problem there. Line 50. I think that's my JavaScript habits coming through. Okay. So we'll run this test and hopefully it will fail because we've tried to use it won't even compile because we've tried to use K. We've declared a K and we've not used it. Oh, it's also complained undefined R. Candlestick test go 41 undefined AR because I called that AR1. Okay, so K declared and not used. There you go. So what we do instead, because we've not used it, is we replace it with an underscore and we say that's saying take that result and just forget about it. Now when we run our test, it's passed. Okay, good. So that's the basic test that we needed to do. So that's that part, and we've introduced this new range technique, which will save us a bit of work later on as we go through some more of this stuff. Now, back to the game where we make our struct for player. So I'm gonna create a struct for player. Type capital P player struct, and what does our player need? Well, first he needs his deck. Then, and that deck will be a slice of int, won't it? He will need his hand, which will also be a slice of int, and he will need a score, which will just be an int. So now we can always work with this. Now I'm going to put make a constructor method for this, because most of the time we're just going to want to make a new player. They're going to want to work in exactly the same way, so we might as well make a new player method. So func new player. This makes it really easy for people to, when they see your code and go, oh, what does that method do? It says new player. Well, it's going to make a new player. What do we need for a new player? Actually, we don't need anything. We're going to establish it ourselves. And so, but of course, so we make a new object. This returns a type, a pointer to a player, I think is probably the best thing to do. A pointer to a player. So that means we can shift it around a bit easily and not worry about losing some data. So we've made our new player. Well, we haven't yet. This is actually really basic. Return. The easiest way to make a struct is just to do this, is to fill it in. So you give its type. Actually, pointer to, that's what the and means, so we're returning a pointer to, and then we just fill this. If we didn't put the and, it would just return the player straight up, all of that data as one string of bits, basically. So the first thing we're going to add is a deck. And that is going to be a new deck. So I think we can just simply call that function. We've written it already, haven't we? Make deck, and that returns a slice of int, so that will fit there perfectly. A slice of int, make deck. And then we're going to have make on another slice, which will be their hand. An int, that's a thing of ints, and we'll set it to 0 initially. And put a comma there. And the last thing is its score, and of course a new player's score will be 0. Now this isn't quite right, because now we've made the deck and he hasn't drawn any cards, and actually every new player is going to start with 3 cards drawn. So we need to include something in that to draw those 3 cards for them. And my actual feeling here is I want to draw the 3 cards in a separate function. So here is a really cool thing that you can do with structs. You can actually give them a method that belongs to them. Func. Now this func operates on any kind of player. See, a pointer takes a pointer to self. We'll call it self. It's me being Python-esque, but it'll do. Self takes a pointer to player, and then we give it a name, which is draw card. We'll say draw cards, and we'll take an int of how many cards we want to draw. Then we actually, this should be surprisingly easy. Let's and this will return. It doesn't return anything. This is a modifying method, so it actually doesn't need to return anything. Then there could be a case for returning an error if there are no cards left to draw, if it couldn't draw that many cards. I'm not going to do that just yet. We might find that we want to later. In this case, we're going to draw 3 cards. Well, no, in this case, so we need hand. So self.hand equals append. I think this might work surprisingly tidily. Let's have a look. Self.hand.append. Well, obviously self.hand is the actual array we're appending to. And self.deck, something I haven't yet shown you, is slices. Like a slice can be sliced. If you've got a slice of anything, you can actually take a smaller slice from that slice using a very tidy notation. Self.deck. And here we want basically the first 3 cards from what is currently in self.deck, or the first n cards. So I think we do :n. And then we'll put 3 dots on the end. And I think that will return every element, that will append every element of that to the end of that. And of course self.deck equals self.deck, and then we're going to take the other slice of that, m-1 to the end of the array. So this basically, if it's empty on this side, it goes all the way to the end, and if it's empty on this side, it goes all the way to everything from the beginning up to n, and everything after m-1 to the end. I might have got these numbers wrong, and we will test that in a second. But here's the thing, I can't actually get rid of this, but I can say res : equals, and then from here. And here we do res dot, and here's how it really works nicely. Draw cards, and this should probably be a capital, because in Golang capitals make it public. So if anyone else wants to use it, they can. Draw cards n, and n will be 3. And then the last thing we do is return res. Okay. Now Candlestick has a main method. So now we have this new player method. And in theory, we should end up with players with 10 cards in their deck, 3 cards in their hand, and no score. We no longer need this all decks thing. We just need to make players. So, Control D. Oh. Players colon equals make a slice of players, no, a slice of player, and that will contain 4 players for now. And then in our for I equals 0 to 4, all decks at I equals, well, it's not now all decks, it's players, and this is new player, and that doesn't take any parameters. We'll replace this and see what that prints out. Go run, isn't it? Go run candlestick.go. Cannot use new player type pointer as type player in this assignment. Oh, of course. Players is actually supposed to take in a slice of pointers to player. And of course, out printing out a slice of pointers prints out a slice of pointers. So this is the locations in memory of the 4 different players we've got. Probably the best place to print this actually would be func.println, no, printf %s, %s, %d, and see what result we get in players I dot deck, players I dot hand, dot score. And I didn't make any of those things uppercase, did I? I don't think it's that important right now, really. It's a top level function anyway. And let's put some new lines on this, shall we, to make it slightly clearer what we're doing. We'll put a new line here, and a new line, here, and another new line here. I think would probably be a good idea here as well. There. So I want to see what we're getting. Better to make a test of this. There we go. 5, 1, and 11. That's 3 long. That's perfect. How long are these? That's 3 long. The last element of that is 6. Aha! There is an overlap. I did this wrong. So that one is correct, and that one is incorrect. That makes sense, I think. I think the thing to do here is actually to write the test method that checks this. Func test new players t pointer testing dot t, and again, new player is actually a nice pure function. So I think, yeah, it just takes no parameters and returns. No, it's not pure. It's not completely pure, but it should be easy enough to test because it doesn't always return the same thing. That's the thing that makes it not pure. But it does always return basically the same thing. It always returns a player with some cards. So for I colon equals 0, I is less than 10, I plus plus. This is just to make sure it happens the same for each of them, right? Res colon equals new player, platter, new player. If res dot deck dot, oh, we need a length. If length deck not equal to 10, t.Log fail, and funct dot print f. Deck not 10 long. Okay, and the other thing is if hand does not equal 3, t.Log fail, func dot print f hand not 3 long. Honestly, if this keeps succeeding, if this starts failing, then I'll make the test more accurate, but I'm expecting it to get here. And now I need to get any contains working. So for I equals, no, we've done I already. For k comma v in range, so that's colon equals range of res dot hand if contains res dot deck res v, then we need to fail our test as well because there shouldn't be any overlaps in these. Funct dot print f hand, no, overlap percent d comma, and that will be v. That's probably enough for now. I'll get more details out of that later. But if we run go test, let's see what we get. Failed because it couldn't compile. Goes to 60, undefined deck. Bad habit. Deck belongs to res. Res dot hand. Let's try that. Still 2 more. Undefined t. because of course it's named T, it's just the type of T. Oh, and we forgot to include it here, t.fail. non-bool used as if a condition. Oh, yeah. It's greater than 0. K declared and not used, of course. I actually just declared it lazily because I didn't know if I was going to use it. Turned out I didn't want to. Dec not 10 long, overlap 10, dec not 2. Overlap, yeah, so the answer is it's not working. I think I know why, but now I've written the test, it's going to be easier to test. It's going to be easier to make sure I've got this correct. So I expect this should be the right answer here. And that passed the test. Good. And in all of that, I never got around to fixing that thing I was supposed to fix at the very beginning of this, which is the fact that decide trick returns the wrong result. Decide trick is supposed to return the winning player. So what I'm going to do is I'm actually going to make it return 2 results. It's going to return the winning player and the winning card. Question is, which one should it return first? I think it should be winning player, winning card. Returns... Okay. Returns winning player, comma, winning player, comma, winning card, or returns -1, -1 if everybody put in a card that was not unique. We're going to have to rewrite the test for this as well, but that shouldn't take too much work. The thing we haven't done is we don't actually know who the who actually won this. So winning player currently equals 0. No, it should equal. Oh, it doesn't actually matter, but I'm going to put it to -1 now. And that counts through uniques. We actually need to count through the original array that we received, which was called AR. For I'm going to use KV currently equals range AR if V equals winning card, winning player equals K. And that's where K and V come in handy. You get an index and a value, and that's really tidy. So if the value is matched, then the index is actually the winning player from this array here. So now we need to change our test so that we get our expected result is so up here, test stuff. We're actually expecting 2 things here, so it's expected so I'm going to rename these expected player and exp card, which is also an int. And player comes first, so 4 here is 0, 1, 2, 3, 4. 3 is 0. Um, 1 is 0, 1, 2, 3. And 6 is at 0, 1, 2, 3. So these are our expected results. We never put a fail test in there where actually everyone put in the right thing. So let's do that. Testable table int. And so in this case, everyone has put in the numbers 3, 4, 3, 4, 3, 4. And our expected results will be -1 and -1. So it's squiggly brace, comma. Okay. And now we have 2 expecteds. So this is now our P and comma, and this also returns our C, which is result card. So, and if our C, if our P, if our P does not equal tab.exp P, then we fail test layer, and this can basically copy here, and this one will be RC tab. Now I've introduced this KV thing, I feel like I should actually switch it out. K comma V colon equals range on tab, and then this tab I is V. That's V. This also has the advantage we can actually put out the position in the table it failed as well. Well, we could have done that anyway. And this isn't player. This one's player. This one's test card. And the last thing it needs to do question we don't expect it. RP. This one should be R. This should be EX expected P. This should be P, and this should be expected and that should cover the test, I think. Go test. 72, not enough arguments to return. Yes. No. Chemistry.go 72, yeah. So that is that problem. 72. -1. 99. I never fixed it. I decided on the order and then went straight to testing. Winning player. There you go. So that returns winning. Oh, platter. Why do I keep getting the... Okay, let's try that again. K declared and not used. Oh yeah, I was planning on using it actually. The reason I wrote K here was because I was thinking I'd get a line K. I'll do that, line %d colon, and then right over here we can put a K comma. The same here. Line and over here. Aha! It is responding with the wrong results. So, line 1, line 2, and line 3. But not line 0. And not line 4. Aha! No, there's the mistake. It's here actually in the test. That's the weird thing about testing though. The mistake can be in the test or in the actual code. Yeah, we passed it now. The mistake was, in case you didn't see that, I'd forgotten to make it about the card result in one small place in that test. So, good. Hopefully testing is starting to make sense to you now as to how we do testing. So now we've introduced this new struct for players. So hopefully you'll see that you can add anything you like into a struct, any kind of other type, with the exception of itself, unless you make it a pointer. And you can have a function that works on any struct. So draw cards actually happens, but you could have made that 4 cards and 3 cards. And at any point with those players, we can make them draw more cards. So I got a challenge for you, and I want you to use the asker thing that we made in one of the earlier lessons way back when, to ask the user to choose one of the cards in their hand. Okay, so if they choose one card from their hand, and then you need to make sure that the card they choose is in their hand. If it's not in their hand, you need to ask again until they choose one that is in their hand. Hopefully that makes sense, and I'll see you next week where I will do that challenge and then carry on, and we'll get this game so that it's playable. See you soon.